So this is the candle lab. It's a lab where we're just doing some observations of candles. Um, and, and these are candles in different states of burning. So we're going to talk about them. So here's the candle. And these are the pieces. I have this soft wax, right? So I can draw on it. It's pretty soft as compared to the metal on the outside. This is its container. So I have a container, have a whole bunch of metal, and then this piece of cotton sticking up from the middle is called the wick, and it's a piece of cotton and it has wax coating it. So those are the components of the candle. I'm using a tea candle. It's the most common candle that people can buy. And when a candle burns, you may have noticed that what's disappearing is the wax, and the wick, while it's getting shorter, seems to remain the same height all the time. So here is one that's burned for a long time, and the wick is about that tall. And here's another wick that I let burn for a little bit, and it's pretty close to exactly the same thing. So this is our candle, and one of the things you're supposed to do is make observations of the candle and then describe it in different ways. So one way to describe it is its physical properties, like what it looks like. So we can come up with several descriptions. One way to know what description is how is the wax different than this container, and the more differences you come up with, the more properties you end up. How is this candle different than the top? How is it different than water? So think of all the differences, and then as you go along, you'll create new properties that we'll cover. We can change it. We're going to see some of those physical changes when we do the light, but this is a physical change. I have now drawn in it, and what I did is I cut the wax up. But did it change from a different substance? No, it's still the same wax. It's just that I have these little shavings now. So that's called a physical change because I wasn't able to change it into a new substance. A chemical change is one where we create a brand new substance. So let's light our match. Not only is the head changing, usually there's a different smell than just the wood. If you just smell the wood, it doesn't have that same sulfurous smell. And I'm going to light the candle, which is something you need to do. And when you light the candle, you want to keep a match. So we don't really want the match head to burn yet, all the way down. However, you're supposed to have several matches. And if you don't have matches, you can have toothpicks available to do the rest of this lab. Let's adjust the lighting. There we go. So when you light a candle, you get a chemical change, which leads to this release of energy. So changes are often associated with energy change. So I can't affect the wax unless I push on it or use a mechanical energy to cut it. And in the same way, I can't create a chemical change without first lighting the match to begin the change. So you have to have some kind of change involved, some energy change involved whenever you have a chemical change or a physical change. So I'm going to a chemical property is a description of change. So wax burns and creates a golden glow from a fire while it melts. So when wax burns, you get a golden glow without much smell. And so that description is a chemical property. And a chemical change is describing the actual chemical change. Pause the video here to write down the first 3 answers on the worksheet. Okay, so we're going to begin looking at the candle and its chemistry. And it says to light the candle, but I lit the candle to let you see a physical change taking place in the candle. You can see the liquid being formed, although maybe not so much. When the candle's burning, it forms a liquid here, and that liquid is a physical change because that's still wax. The liquid is not changed into a new chemical. We have the solid wax on the outside, and we have this liquid wax on the outside. The other thing I'd like you to notice is that when I lit the wick again, the wick didn't burn. Like when I light the matchstick on fire, what we see is we see a change along the matchstick as it burns, but that's not happening for the wick. We're not seeing that, and we'll come back to that in just a second. So we have our candle, our match burnt, and we have our candle going, and we kept a burnt piece of match, although we could easily create another one. You'll now need to do questions 4 and 5 on the worksheet. And then we got that. Okay, so you have to do modeling of a solid, liquid, and gas, and we talked about this yesterday or the other day in notes. And if you don't know, you should look up atomic models of solids, liquids, and gases. So it says to use ovals or circles. I was able to type them in and create solids and liquids and gases with capital O's. So you could do the same thing, or even zeros would be ovals. So with all this talking, I've let the candle burn for a while, and I want to point out what I had said before. We're going to blow this out again. Need another match. So what's happening to the wick during this burning, right? As we're getting burning happening, I'd see the physical change happening around the outside, but at the same time, that wick is sort of like a participant, but not a participant. It doesn't seem to be changing for anything. Okay, you should stop the video now and go through the questions that lead up to the next experiment. Okay, so for the next experiment, we're going to use our matchstick that was burned, but also it's enough so I can hang on to it and see. And so what we're going to do is we're going to see what the properties of the wick are. So essentially, this is how the wick is acting. I put the wax in here, and you can see that that what's happening is, well, you can't see, but it's actually getting wet from here all the way up to here. When you take a wet rag or something and put the tip into water, you can see water moving up through the wet rag or towel or napkin, you can see liquid moving through. So if you remember, liquid is free to move freely, and it ends up not having a problem hanging onto the sides of the matchstick, and actually finding little pores and holes through the matchstick and climbing up, and that's called capillary action. So one of our observations is that a burnt substance will reach a point where it's either all gases or it will leave behind a solid that can no longer react because the combustion process is completed. But the way a candle works is to use that kind of material to continue to create a flame with this liquid wax. And we'll learn that it's not really the liquid, but something else. I get to use a screen, but I did want this to be an at-home activity. So you can make a screen by taking a piece of aluminum foil and making holes in it at a regular pattern. And then I sort of offset them and I try and create a pattern. Now I don't need very much of a screen. I just needed to cover the flame. So there you go. I have created this screen. I'd love to be able to see through it, so I'm actually going to make bigger circles in my screen so I can see through it. And if you accidentally make the hole so big that you combine holes, it's unlikely to be a problem. So here I'm enlarging all my holes. I see a place where I probably could have another hole there. And that one wasn't very big. I think I can get a hole in there and there. So you make a screen that you can see through. And, sorry, there's heat rising from the candle. Okay. Here you go. So remember, we don't have to do all of it. That's kind of effective. Okay, so there you go. Nice. Okay, so it sort of works, and if I could get the holes a little closer to each other, maybe I'd have an even better screen. So by screen, I want something like this. Many screens are made out of plastic. You need a metal one for this to work well. Okay, so one of the things that people love, I'm going to light up one of the other candles. Because what happens is I often snuff out the flame. So we put this down, and the flame is unable to come through, right? So our first observation is that by going close to the wick, we get this smoke, but we also don't see a flame coming through. So the flame is unable to get through, even though clearly things are passing by. And then the second thing I've already mentioned is the smoke that forms when you bring this down. So with this smoke comes an odor, and so not only do I have a smoke, but I have odor coming through. Now, I can see this, but I know what to look for. So I'm going to switch to the screen because I can see more. And I'm going to lower this. Look at that. I ruined my gigantic big flame that was going to be perfect. I lower it I don't know if you can see the smoke because it's black on black, but you should be able to see the circle, and you can see right down into the wick. So I have this cup around the wick, and so these are too hot. So what I have is I have the wick standing up and the flame surrounding the wick, right? So I got this little cup and this little wick standing up in the center of the cup, and the cup is the flame. The flame is round. So I don't have a top of flame that I see here. So I bring it down, and again, it's hard to see. But I've created a circle around my wick, and around that wick is the flame. So you can try your screen and see if you see the same circle again, which I do. It's just harder to see through that screen. We're going to blow out the candle. And one of the things that happens when you blow out the candle is you get this smoke, right? And then you can relight the candle and the smoke disappears. So, and that happens with a lot of things, like paper will continue to smoke, campfires continue to smoke, all those things continue to smoke. But you might be able to do this. Blow out the candle, and then without touching that worked, but I don't know if you could see that. So let's make a better view. Readjust okay, maybe that'll work. And let's get our match. So try it one more time. And I don't know if it's any better. Come on. Okay. Just like the kids, I blow out everything. Dang. Every year that happens. Okay. Ready? Only the candle. Blow out the candle. Oh, amazing. I've never had it do that. So, good thing it was on video. We need to have a flame again. So I'm going to come over here and see. One more time. Let's see if this get my yay. Okay. So what that's an indication of the fact that if I take liquid wax here's my liquid, and I try to catch it on fire. So now I'm just going to try to catch the liquid on fire, right? Nothing. No fire for the liquid. right? And certainly there's no fire for the solid. Here's solid wax. All that solid wax does is melt, right? So something's happening to allow that to happen, right? That change, that lightning strike of flame to go down there. Perfect. Okay, so now we have to wrap up the experimental observations of what's happening. So it's time to wrap up, and what you'll need to do is answer those observational questions that provide evidence, and then you're going to do a paragraph and refer back to those observational evidence statements and complete the paragraph where you have all the sentence frames. That's it. Then you'll be done with the lab. There is another worksheet with some questions referring to it that help you connect it to what we are learning. Thank you, and if you did the lab, great.